there are a variety of ways of writing the organization of electrons in an atom. We're going to look first at orbital diagrams. Orbital diagrams, and the electron configurations we'll look at later, are both filled lowest to highest energy. So they start at our n equals 1, then 2, then 3, and so on. We want to fill each orbital with one electron before pairing. We'll look at how that applies once we actually start looking at the orbitals. So for example, if I have sulfur, if I look on the periodic table, I can find the atomic number for sulfur. That'll help me to determine the number of electrons, because remember, the atomic number is equal to the number of protons, and in an atom, an uncharged atom, the electrons are equal to the protons. So that gives me electrons of 16 because we have an atomic number of 16. 16 protons, 16 electrons. If I look at where sulfur is on the periodic table, that'll also tell me which level it is. So remember what we looked at with the S and P blocks. That will help you to determine which blocks are going to be involved in this. If we look, it's in the third period, so the third row down. So we have 1s, 2s, 2p, 3s, and sulfur is in the p block, so it's 3p is the last level. So these are the 5 levels that we're going to have, so the orbitals. Now we want to actually look at how many suborbitals are in each and how they're going to fill. So this, I've rewritten it. We have our 1s. There's only one orbital in the 1s suborbital. We have 2s, has 1 again because it's an s. So all the s's only have 1 spot. Each p has 3 different possibilities. So I have 3 different boxes here. What I'm going to do is I'm going to take those 16 electrons and I'm going to add them into my orbitals. So first I'm going to add to my lowest energy, so that's going to be our 1s, I'm going to add 1 electron. The second electron that I add has to also go in this level. So I have paired electrons. Notice that one of them is an arrow going up and one going an arrow down. This is how we remind ourselves that we've got those opposing spins. So I've gotten rid of 2 of the electrons in this. Now I'm going to complete this with the other electrons. My next electron needs to go into the 2s orbital, and then it would pair. Once I go to the 2p, I put 1 into the first box, but it doesn't have to pair yet. The next electron can go into the second p orbital. Then the third. Now they will start pairing. So now I've taken care of 8 of the electrons on this level and 2 from the previous. So I have 10 electrons so far in my orbital diagram. I'm going to continue into the 3s and then into the 3p. 1, 2, 3, and I have 1 more electron left. And that will give me my full orbital diagram for sulfur. We can also abbreviate this diagram by looking at the last noble gas that we pass getting to sulfur, that's neon. We can put that into brackets, and then we can complete the orbital diagram. We'll also look at how that applies to electron configuration. Now, most of the time, we don't want to have to draw out the entire orbital diagram, so we have this shorter notation, electron configurations. So for sulfur, the electron configuration is 1s2, 2s2, 2p6, 3s2, 3p4. And the way we get that, so I'll go back to my orbital diagram. This 1s has 2 electrons. So I have 1, the number 1, lowercase s, and 2 as a superscript. These electrons are the 2s level, and I have 2 electrons in this level. 2p, I have 1, 2, 3, 4, 5, 6. 3s, 1, 2. 3p only has 1, 2, 3, 4. And so you'll notice that it matches here. This can also be written as neon, 3s2, 3p4. This neon has a configuration of 1s2, 2s2, 2p6, which you'll notice is the same as this part. So I'd like you to take a moment to write the electron configurations and the noble gas form, if applicable, for each of these atoms. Pause the video and then check your answers. These are the answers to those questions.